Okay, let's go over these quiz questions. This first one is on integration by parts. So let's just do the first one first, and let me remind you about the formula. So the formula is that the integral of u dv is equal to u times v. Whoops, what happened here? Sorry, my computer is... Okay, is equal to u times v minus the integral of v du. Okay. So the whole thing here is to pick u and dv correctly, and then the rest kind of works automatically. You know what? You want this integral that you end up with to be easier than the one that you started with. That's kind of the whole point. Alright, so let's try it. Let me copy it over here. This is the integral x squared times natural log of x dx. And natural log loves to be u. So let's go ahead and give that a try. So make u natural log of x. That means du is equal to 1 over x dx. Okay, so just take the derivative of the thing that you make u. And now dv has to be everything else. So what's left is x squared times dx. And then to get v, you just integrate this. So secretly v is the integral of this stuff, so x squared dx. But usually we can just do it in our head, right? So right now I can do the antiderivative of x squared in my head. It's x cubed over 3. And forget about the constant for a second. Okay, so now use the formula. Alright, so here's the formula, and I just copy this stuff over. So the original integral is the same thing as u times v. So here's u is natural log of x. And hold on, I lost my cursor for a second. So it's natural log of x times v, which is this, x cubed over 3. Okay, so take away. Sorry, I think I know what's making my computer slow down. I'm going to close it. If I could just please, thank you. Now here, the way I write it, I always do u and du ends up on the bottom, and I do dv on the top, and v ends up down here. So the way I set things up, it's always just the last line here. But if you want to look back to the formula, it should be v du, right? So here's v and here's du. So what have we got? We have x cubed over 3 is v, and we want to multiply that times dv, which is 1 over x dx. Great, and let me just work this one out. Okay, so these things, you have an x cubed here and you're dividing by x. So this integral becomes x squared over 3, right? dx, after you cancel those x's, and I think you can probably do that in your head, right? That's just 1/3 x cubed over 3. Sorry, it froze. I don't know why I can't. I'm sorry that my computer never works quite right. Over 3, and now I add a constant here, plus c. Okay, great. So to copy everything over and give the actual final answer, the final answer is u times v, which is that stuff, so natural log of x times x cubed over 3, and take away 1/3 x cubed over 3 plus c. And that's it. Okay, so let me push this stuff down. Maybe I'll circle this just to, maybe somebody's watching with the volume off or something. So that's the answer. And push that down, and let's do the next one. Alright. So I can leave the formula there, but okay. So this next one is just natural log by itself. So this is an important one to know how to do because, you know, frequently, or in calculus 2 anyway, frequently you want to know what the antiderivative of natural log is. So how do you do it? So just make u natural log So u is equal to natural log of x, and that makes du equal to 1 over x dx. Alright, and it seems like there's nothing left for dv, but there actually is. Okay, so dv is going to be equal to dx. That's what's left over. So then, v, secretly we're integrating this thing. The integral of dx is x, and that's it, right? So now let me use this the formula here. So u times v, that's going to be x natural log of x. And I'm going to take away the integral of this bottom line, right? So notice I'm going to do it all in one step now. I'm going to multiply du times v, right? And it's 1 over x times x, so they cancel, and what gets left is dx. And so the answer is x natural log of x minus x plus c. And that's it. And I've involuntarily memorized that now. Maybe you have too, but that's the way you do the integral of natural log. Let's go look at, I did say plus c on the other one, right? Let's just assume I did. And so that's the end of the first one.